There will be 4 free response questions on the AP Precalculus exam. This video is modeled after FRQ 2. It's about exponential modeling and average rates of change. Let's pretend it's from the 2004 AP Precalculus exam. If you appreciate the content, please give it a like. After Mr. Passwater missed a day of school, a rumor began to spread that he had won the Powerball lottery and moved to Japan. Initially, 7 students knew about the rumor. They were the ones who started it. After 2 hours, t equals 2, a total of 15 students had heard the rumor. After 6 hours, t equals 6, 67 students had heard the rumor. The number of students that have heard the rumor can be modeled by the piecewise function r, given by this expression, where r of t is the number of students that have heard the rumor at time t hours since the rumor first began. A Part 1. Use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for r of t. Every input-output pair can be used to write an equation. We are told that at t equals 2, 15 students had heard the rumor. So t equals 2 is on the interval from 0 to 6. So let's plug in 2 for t and set that equal to the output value. That gives us 7a, and we are plugging in 2 for t. So that's going to be 2 divided by 2, which is 1. And this should equal the output value of 15. So there's the first equation. At t equals 6, 67 students had heard the rumor. Let's use this input-output pair to write another equation, this time involving the expression with a b. If we plug in 6 for t, we get negative 213.29 plus b times the natural log of 6. And this should equal the output value of 67. So that's it for A Part 1. We have written 2 equations that can be used to find the values for constants a and b. A Part 2. Find the values for a and b as decimal approximations. Let's start with the blue equation. Dividing both sides by 7, we get a is equal to 15 over 7. A to the 1 power is just a, so I am ignoring that. So we have already found the value of a. We just need to find the value of b. Well, this equation has no a in it or anything, so we can just solve this equation completely independently from the first equation. Often we have to plug the value of the first equation back in, but not this time. So let's add 213.29 to both sides of the equation. So the red equation will become b times the natural log of 6 is equal to 67 plus 213.29. I'm going to just leave it like that, or am I? No, I'm not. So 213 plus 67 is 280. So b natural log 6 is equal to 280.29. Now we divide both sides by the natural log of 6, and we get b is equal to 280.29 over the natural log of 6. Let's put this into our calculator to find the decimal approximation. First, reset your calculator by hitting second plus 712. That's second plus 712. Now, what were we doing again? 280.29 over natural log 6. Make a fraction by hitting alpha and x. and that was 280.29 divided by the natural log of 6. Kabam! 156.4328. The College Board will accept 3 decimal places. However, students often will make a mistake when they try to round to 3 decimal places, so I recommend always using 4 decimal places and never try to round. So just write b equals 156.4328. Let's go back to the calculator. I'm not sure if we will need this value later, but just in case we will, let's store this into letter B on the calculator by immediately hitting store and then alpha B, enter. Now if we need this value later, we can use the letter B without losing any decimal place accuracy. Speaking of decimals, we were asked to write the values of A and B as decimal approximations, and here I've written a fraction. So let's go back to A and record our answer as a decimal approximation. So 15 divided by 7, 15 divided by 7. So that's 2.1428. Just for fun, I'm going to store this into letter A as well. Store alpha A, enter. B, part 1. Use the given data to find the average rate of change in the number of students that have heard the rumor in students per hour from t equals 2 to t equals 6 hours. Express your answer as a decimal approximation. Show the computations that lead to your answer. The function r of t gives the number of students that have heard the rumor. So the average rate of change will be given by this expression. For the interval from 2 to 6, the average rate of change of r will be r at 6 minus r at 2 divided by 6 minus 2. Always show this setup. Don't skip this step. In the setup, we were told that r at 6 is 67 and r at 2 is 15. 67 minus 15 is 52. So we have 52 over 4, which is equal to 13. B, part 2. Interpret the meaning of your answer from part 1 in the context of the problem. When you interpret the meaning of the average rate of change in the context of a problem, your answer should always have these 3 parts to it. First, you state the meaning of the function involved in the average rate of change with the units. Then you say whether that function was increasing or decreasing and include the units. And then you say the time interval over which the function was increasing or decreasing with units. First, we state the meaning of the function. We can find that right here in the setup, and I strongly recommend copying the wording from the setup. So I'm going to say the number of students that have heard the rumor, and the units are simply students, so I've included the units. Next, I say whether this value is increasing or decreasing on average. Since the average rate of change is positive, the number of students that have heard the rumor is increasing. If the average rate of change had been negative, then the number of students that have heard the rumor would be decreasing. Now we need to include the units. The number of students that have heard the rumor is increasing by 13 students per hour on average. Finally, we need to mention the interval over which the number of students that have heard the rumor is increasing, including the units. So that's it for B part 2. Remember, whenever you interpret the meaning of the average rate of change in context, your answer should have these 3 parts to it. First, state the meaning of the function that you're taking the average rate of change of. Make sure you include the units. Then, say whether the value of that function is increasing or decreasing, and by how much, and make sure you include those units. And then finally, mention the interval over which you are calculating the average rate of change and include your units. Let me mention one more small detail going back to the red part. I mentioned that if the average rate of change is positive, then the value of the function is increasing. And if the average rate of change had been negative, for example, let's say it had been negative 13, then the average rate of change would be decreasing. But what I want to emphasize is if that were to happen, and so we said decreasing, we would not put a negative sign here. No. Instead, we would still say 13 students. If this was a negative 13, we would say the number of students that have heard the rumor is decreasing by 13 students per hour, and the rest of it is the same. The negative is included in the word decreasing. In fact, if you say decreasing by negative 13, technically that means that the number of students who heard the rumor is increasing. Anyway, this is the answer to B, Part 2. B, Part 3. Consider the values that result from using the average rate of change found in Part 1 to estimate the number of students that have heard the rumor for times t equals p hours, where p is between 0 and 6. Are these estimates less than or greater than the number of students predicted by the model R for times t equals p hours? Explain your reasoning using characteristics of the average rate of change and characteristics of the model R. Between t equals 0 and t equals 6, the exponential model applies. Here's a sketch of exponential function r of t on the interval from 0 to 6, including the one input-output pair that we were given in the setup. I made a small mistake right here. The input-output pair we were given is actually 2, 15, not 2, 12. I chose not to re-record the whole video because it doesn't really affect the answer. But every time you see a 12, it should be a 15. That includes in a moment when I write the equation of the secant line. You're going to see a 12 right here and right here, but it should really be a 15. When they talk about using the average rate of change to estimate, they are talking about using a secant line to estimate, specifically the secant line through the 2 points used to calculate the average rate of change. In B Part 1, we calculated the average rate of change of r of t on the interval from 2 to 6, and that turned out to be 13. That means the secant line on the interval from 2 to 6 has a slope of 13. The slope is the average rate of change on this interval. Let's find an equation for this secant line so we can refer to it in our explanation. To write a linear equation, we love to use point-slope form because all you need is a point and the slope. Let's use the point 2, 12 and the slope of 13. So we have y minus y, so y minus 12, is equal to the slope, which is 13, times t minus t. So that will be t minus 2. This is an equation for the secant line, but let's get y by itself so we can sort of call it y of t. So adding 12 to both sides, we get y is equal to 13 times t minus 2 plus 12. And now we can sort of call this y of t, the equation of the secant line of R of t on the interval from 2 to 6. When we talk about estimates, we are talking about values given by this secant line. Notice that the secant line is above the curve R of t on the interval from 2 to 6. So any estimate is going to be greater than the actual value of R of t on this interval. And this is because R of t as an exponential function is concave up. When a function is concave up on a given interval, the secant line will always be above the curve. Remember, we need to answer the question, are the estimates less than or greater than the number of students predicted by the model on the interval from 0 to 6? Watch how I reflect the words of the question in my answer. Estimates are given by y of t, the secant line of r of t on the interval from 0 to 6. Since y of t is linear and r of t is concave up on the interval from 0 to 6, y of t is greater than r of t on the interval from 0 to 6. So the estimates are greater than the number of students predicted by the model. There's a saying that says a picture is worth 1,000 words. Including a picture like this one is not mandatory, but it will increase the likelihood of you earning full credit on the AP exam if you do. That's because sometimes if you accidentally leave out certain phrases in your wording, it will be covered by the picture. So I wouldn't count on that. Obviously, try to cover all of the key points that you need in your verbal explanation. But having a picture like this one is a little bit of an extra insurance policy. Highly recommended. Part C. The model R is valid on the interval from 0 to 12 hours. Explain how the range values of the function R should be limited by the context of the problem. Range values refer to the possible output values of R of t. Since model R is only valid for input values on the interval from 0 to 12, we can find the range of R of t by finding the corresponding output values for each of these input values. At t equals 0, R of t is 7. What about at t equals 12? Remember, we found the value of b back in A part 2. If you didn't do it earlier, store this value into letter B on your calculator right now. Kabam! And then hit store alpha B, enter. We can now find R of 12 by entering 213.29 plus B natural log 12 on the calculator. We stored all of these decimals into letter B, so we can hit alpha B right now and avoid losing decimal place accuracy. So we can do plus B natural log 12. So there's the corresponding output value for the input value of 12. So according to the model, at 12 hours, approximately 175 students have heard the rumor. For t greater than or equal to 6, R of t is a logarithmic function that increases without bound. However, since R at 0 is equal to 7 students, and R at 12 is approximately 175 students, the range of R of t must be limited to values from 0 to 175. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.